Welcome back to Click Future's Tech Convergence series, where we explore the fascinating intersections of today's most revolutionary technologies. In our previous episodes, we've explored sentient machines, the quantum internet, brain-computer interfaces, and digital twins. Today, we're looking skyward to examine a profound shift in humanity's relationship with space, the new space race. Unlike the Cold War competition between superpowers, today's space race features a complex interplay of private companies and national space agencies. Companies like SpaceX, Blue Origin, and Rocket Lab are challenging the traditional dominance of NASA, ESA, and Roscosmos, while simultaneously forming partnerships that are accelerating our return to the Moon, our journey to Mars, and our expansion throughout the solar system. From the launch of Sputnik in 1957 to SpaceX's first crewed mission in 2020, the economics, technology, and goals of space exploration have transformed dramatically. The convergence of private capital, advanced manufacturing, artificial intelligence, and a renewed national interest in space is creating opportunities that were unimaginable just a decade ago. In this episode, we'll explore how private companies are revolutionizing access to space, examine the evolving relationship between these companies and national space agencies, consider the economics of this new space ecosystem, and contemplate the implications for humanity's future as a spacefaring civilization. The landscape of space exploration has been transformed by the emergence of private space companies with capabilities that rival or exceed those of traditional national space agencies. SpaceX, founded by Elon Musk in 2002, has perhaps been the most visible disruptor. Their development of reusable rockets has dramatically reduced launch costs, from about $54,500 per kilogram to low Earth orbit in the Space Shuttle era to less than $2,720 today with the Falcon 9. Their Starship system aims to reduce this further to just a few $100s per kilogram, potentially revolutionizing access to space. Blue Origin, founded by Amazon's Jeff Bezos, has focused on both suborbital tourism and developing the heavy-lift New Glenn rocket. Their long-term vision, as Bezos has stated, is to move heavy industry off Earth to preserve our planet while enabling a space-based economy. Smaller companies like Rocket Lab are carving out niches in the small satellite launch market. Their Electron rocket, which can deliver payloads of up to 300 kilograms to low Earth orbit, represents a new generation of rockets designed specifically for the booming small satellite industry. In space tourism, Virgin Galactic and Blue Origin have begun suborbital flights for paying customers, while companies like Axiom Space are planning private missions to the International Space Station and eventually their own commercial space station. Dr. Carolyn Thompson, a space industry analyst, explains the significance. What we're seeing isn't just a change in who builds and operates rockets, it's a fundamental shift in the economics and philosophy of space access. Private companies are bringing Silicon Valley's rapid iteration approach to an industry that was historically risk-averse and slow-moving. This approach is yielding results. SpaceX developed the Falcon 9 for approximately $390 million, about one-third of what NASA estimated it would cost under traditional contracting. And while NASA's Space Launch System has been in development since 2011, SpaceX has developed multiple rocket systems in the same time frame. The key innovations driving this transformation include 1. Reusable rocket technology, pioneered by SpaceX and Blue Origin. 2. Modern manufacturing techniques, including 3D printing of rocket components. 3. Vertical integration, with companies controlling more of their supply chain. 4. Agile development approaches that favor rapid testing and iteration. 5. New business models that don't rely solely on government contracts. As private companies have risen to prominence, national space agencies like NASA have been evolving their approach, moving from being operators of space systems to becoming customers and partners of private industry. NASA's Commercial Crew and Commercial Cargo programs represent this new paradigm. Rather than designing and operating their own vehicles to resupply the International Space Station, NASA now purchases these services from companies like SpaceX and Northrop Grumman. This approach has saved taxpayer money while fostering innovation in the private sector. The Artemis program, NASA's plan to return humans to the Moon, exemplifies this new relationship. While NASA provides overall direction and funding, private companies are developing key components. SpaceX's Starship will serve as the lunar lander. Blue Origin is developing the Blue Moon cargo lander, and numerous smaller companies are contributing technologies from spacesuits to surface habitats. International collaboration is also evolving. The European Space Agency, JAXA, Japan, CSA, Canada, and other agencies are increasingly coordinating their efforts and partnering with both NASA and private companies. The Artemis Accords, signed by over a dozen countries, establish principles for cooperation in space exploration. Meanwhile, China has emerged as a major space power with its own space station, lunar exploration program, and successful Mars rover. While largely developing its capabilities independently, China has expressed openness to international cooperation on specific projects. Jim Bridenstine, former NASA administrator, offers perspective. The role of NASA and other government space agencies is evolving toward focusing on the things that only governments can do: basic research, very long-term projects, and missions where there isn't yet a clear commercial case. We're enabling private industry to handle routine access to space while we push the boundaries further out. This division of labor allows agencies like NASA to focus resources on more ambitious goals, like deep space exploration, fundamental scientific research, and developing technologies that are too early stage or risky for private investment. The transition hasn't always been smooth. Institutional cultures developed over decades don't change overnight, and there have been tensions between traditional aerospace approaches and the more rapid, iterative methods of newer companies. However, the successes of programs like Commercial Crew have demonstrated the potential of this new model. The global space economy has grown from $329 billion in 2016 to over $447 billion in 2022. With projections suggesting it could reach $1 trillion by 2030. This growth is being driven by both traditional sectors like satellite communications and emerging areas like space tourism, in-space manufacturing, and resource utilization. Satellite services remain the largest segment, with communications, Earth observation, and navigation systems generating billions in annual revenue. Starlink, SpaceX's satellite internet constellation, represents a new generation of mega-constellations that could dramatically expand this market. The dramatic reduction in launch costs is perhaps the most significant economic shift. When SpaceX's Falcon 9 entered service, it offered launches at about half the price of competitors. Their reusable rocket technology has further reduced costs, with Musk claiming that fuel and operations for a Falcon 9 launch cost just $15 million. A fraction of the $60 to $100 million typical for expendable rockets of similar capability. This cost reduction has catalyzed investment. Venture capital funding for space startups grew from less than $1 billion annually before 2015 to over $15 billion in 2021. While funding has moderated somewhat since then, the sector continues to attract significant investment. Special Purpose Acquisition Companies, SPACs, have provided another funding avenue, with companies like Rocket Lab, Planet, and Spire going public through SPAC mergers. While the SPAC boom has cooled, it provided a significant influx of capital to the industry. Dr. Sinead O'Sullivan, a space economist, explains, "We're seeing the emergence of a true space economy with multiple interconnected sectors. Launch is becoming a commodity, which enables entirely new business models in orbit. The analogy I use is that we're at a stage similar to the early commercial internet. The basic infrastructure is being built that will enable applications we can't yet imagine." New business models are emerging across the ecosystem. 1. Space as a service. Companies offering turnkey satellite deployment and operation. 2. Data as a service. Earth observation companies selling insights rather than raw imagery. 3. In-space manufacturing. Companies developing technologies to produce goods in microgravity. 4. Space resources. Ventures aimed at mining asteroids or utilizing lunar resources. 5. Space tourism. Both suborbital experiences and orbital stays for wealthy customers. The shift from traditional government contracting to more commercial approaches has been crucial. Under traditional cost-plus contracts, companies were paid for their costs plus a guaranteed profit, which provided little incentive for efficiency. Modern fixed-price contracts and service purchase agreements shift risk to companies, but also allow them to develop solutions more independently and potentially serve multiple customers. The new space race features a fascinating mix of competition and collaboration, with companies and nations both competing and working together in various configurations. SpaceX competes with Boeing in NASA's Commercial Crew Program, yet both are essential partners in America's human spaceflight capability. SpaceX's Starship will serve as NASA's lunar lander for Artemis, while also being developed for Mars missions that may eventually compete with NASA's own plans. The Lunar Gateway, a planned space station in lunar orbit, exemplifies international collaboration. NASA, ESA, JAXA, and the Canadian Space Agency are all contributing components, while using transportation services from private companies. National competition remains a factor. China's space program has made remarkable progress, landing rovers on both the Moon and Mars and establishing their own space station. India has expanded its capabilities with successful lunar and Mars orbiters and plans for human spaceflight. The United Arab Emirates has rapidly developed a space program, including a Mars orbiter. This national competition has echoes of the original space race, but with important differences. As Joan Johnson-Fries, a space policy expert, explains, unlike the Cold War space race, which was primarily about demonstrating technological superiority for geopolitical purposes, today's national space programs balance prestige with practical benefits like technological development, scientific research, and economic growth. On the commercial side, competition is intense. SpaceX, United Launch Alliance, Blue Origin, Rocket Lab, and others compete for launch contracts. In satellite internet, Starlink faces competition from OneWeb, Amazon's Project Kuiper, and others. This competition drives innovation and reduces costs, benefiting the entire ecosystem. Yet collaboration is equally important. The Commercial Spaceflight Federation brings together companies to address common challenges. Standards organizations work to ensure compatibility between systems from different providers, and many companies form partnerships to combine complementary capabilities. Dr. Bhavya Lal, a space policy expert, offers perspective. What makes this era unique is the complex interplay between competition and collaboration. Companies compete fiercely in some areas while partnering in others. Nations maintain their own programs while also participating in international efforts. This creates a more resilient ecosystem than either pure competition or pure collaboration would. The dual-use nature of space technology, applicable to both civilian and military purposes, adds another layer of complexity. Space Force, established in 2019 as a branch of the U.S. military, works with both traditional defense contractors and newer commercial space companies. Similar developments are occurring in other spacefaring nations. Perhaps the most profound implication of the new space race is the potential acceleration of human settlement beyond Earth. Both private companies and national agencies have set their sights on establishing a permanent human presence on the Moon and eventually Mars. NASA's Artemis program aims to return humans to the lunar surface by 2025 and establish a sustainable presence by the end of the decade. The program includes the Lunar Gateway Station in orbit and the development of surface habitats and resource utilization technologies. SpaceX's ambitions extend further, with Elon Musk frequently stating that the company's ultimate goal is to establish a self-sustaining city on Mars. The Starship system being developed is explicitly designed with Mars missions in mind, capable of carrying up to 100 people and 100 tons of cargo. Blue Origin's Jeff Bezos has articulated a different vision, inspired by physicist Gerard O'Neill's concepts of large space habitats in Earth orbit. These massive rotating structures could eventually house millions of people, according to Bezos. While these visions may seem ambitious, the accelerating pace of development suggests they may be more achievable than previous generations of space settlement concepts. Dr. Robert Zubrin, founder of the Mars Society, notes, "What's different now is that we have the technological capability combined with the economic model to make this happen. When the Transcontinental Railroad was built, it wasn't a government project. It was private companies with government land grants. We may see something similar with space settlement." Key to sustainable settlement will be in situ resource utilization, using resources available in space rather than bringing everything from Earth. NASA's MOXIE experiment on the Perseverance Mars rover has successfully demonstrated oxygen production from the Martian atmosphere. The Viper rover, planned for 2023, will map water ice resources at the lunar South Pole. The economic case for space settlement could be strengthened by developments like space-based solar power, asteroid mining, and microgravity manufacturing. These activities could generate the resources needed to sustain large-scale human presence beyond Earth. Dr. Catherine Thornton, former NASA astronaut, offers perspective. Throughout human history, We've expanded into new frontiers when the technology, economics, and social conditions aligned to make it possible. We may be approaching such an inflection point for space settlement. The question isn't really if humans will establish permanent communities beyond Earth, but when and how. This prospect raises important ethical and governance questions. How will resources in space be allocated? What legal frameworks will govern settlements beyond Earth? How can we ensure that the benefits of space development are widely shared? The Outer Space Treaty of 1967 provides some guidance, but was written long before commercial space activities were significant. The new space race represents a fundamental transformation in humanity's relationship with space. The emergence of capable private companies, alongside evolving national space agencies, has created a dynamic ecosystem that is reducing the cost of access to space, accelerating innovation, and expanding the possibilities for human activity beyond Earth. From reusable rockets that land themselves to plans for lunar bases and Martian cities, the pace of development has accelerated dramatically in the past decade. The convergence of private capital, advanced technology, and renewed national interest is creating opportunities that were science fiction just a generation ago. As we navigate this new era of space exploration and development, we face not just technical challenges, but important questions about how space will be used, who will benefit, and what it means for our future as a species. The decisions made in the coming decades by companies, governments, and international bodies will shape humanity's expansion into the cosmos for centuries to come. In our next episode, we'll explore another fascinating convergence, fusion energy, where quantum computing is helping solve one of the greatest challenges in clean energy production. Until then, from Click Future, this has been Tech Convergence. If you found this exploration of the new space race fascinating, please like this video and subscribe to Click Future for more insights at the cutting edge of technology. Share your thoughts in the comments below. Do you think private companies or national space agencies will lead humanity's expansion into space? And would you consider living on the Moon or Mars if the opportunity arose? Thanks for watching, and remember, your future is a click away.